Hello and welcome to Day 1 Content Operations. If you are watching this video on YouTube, you might be best to jump over to sanity.io/learn, where you can follow along with each individual lesson, but there'll be code examples and more explanations all along the way. It might be easier to copy and paste code from that than follow along in the video. Either way, if you are on Sanity Learn, thank you for joining me. We're going to go through this course lesson by lesson, and this course is a special one because there's moments where you might jump out to other courses to explore some topics a little more deeply. Before we start, you should know that this course assumes you have some amount of web development experience. You should have Node installed already. We're going to use PNPM throughout this course instead of NPM, and you'll need to be somewhat comfortable using the command line as well. If that sounds like you, then let's dive in and get started with the next lesson. Let's get you set up with your first Sanity Studio. Before we do, let's explore what Sanity is. If you've heard of Sanity before, you've probably heard of us as a content management system, and that's a really reductive way of looking at Sanity. Sanity is more than just what your website looks like now. It's more about what your business knows to be true and what sort of editorial experiences you can create as a developer for your content teams. The structure of projects in Sanity is that you will have an organization, which is kind of like just a billing entity for all of your Sanity projects. And within a Sanity project, you can have many data sets. And a data set is where you would store all of your text and assets. And typically you just have a production one and maybe a development one as well. We're going to work with just one data set in this particular course. And new projects and data sets and Sanity Studios can all be initialized from the command line. If you don't yet have an account, you'll be prompted to create one in this next step. Let's jump over to the terminal and get to work. So right here on my terminal, I'm just going to paste this command here, which is going to create a new Sanity project. You can see I've added some flags to say I only want the clean template. We're going to create a new project in my account. The dataset name is going to be production. We're going to use TypeScript, and we're going to put this into a particular folder here. I need to select an organization first. You can see I've got quite a few because I develop quite a number of Sanity projects, as you might imagine. And you can see the output path is going to be a folder called Day 1. Inside of that, a folder called Apps, and inside of that, a folder called Studio. And this is important to note because throughout this course, we're going to end up creating multiple applications. So we're setting up our folder structure now to have a Sanity Studio. Soon we'll have a front end, we'll have an app SDK app. We're going to have many, many more. So we need to have a look at our Day 1 folder here. I'm just going to clear my terminal and let's just have a look at our folder structure. I've got apps there. And so now if I open up that Day 1 folder in my editor, I'm using Cursor. We can see here I've got that apps folder with the Studio folder inside. And from here, I can run my Sanity Studio. Now that you've got these files on your machine, let's go and get it started in the next lesson. Your Sanity Studio is an application you'll configure locally, but it will read and write content from the Content Lake, Sanity's cloud-hosted backend. So it's time to get this development server running so we can see what it's like to work with Sanity and start creating some content. Open up your terminal and go into the Apps Studio directory. And from here, we can go pnpm run dev. The first time you open your Sanity Studio, you'll probably need to log into your browser. Use the same account you used when you logged in from the terminal. We can see there's no document types in our Sanity Studio. That's because we chose the clean template when we started. Let's go and take a look at why. So if we open up our Sanity config file, we can see that schema types are loaded here. But this configuration comes from our schema index file, and that schema types array is empty. We need to create some schema types so they render in the Sanity Studio so we can create documents of those types in the Content Lake, and we'll do that in the next lesson. It's time to create our Sanity Studio schema. Before we do, let's talk about what a schema is. It's tempting often to model what you are trying to build or what things look like, but a schema should really model what things are. In this particular course, we're going to create events and artists and venues like we're building something for an events company. This means we won't be creating document types for event pages, but rather those entities, events, artists, and venues, even though they can be rendered onto web pages. This distinction is where we talk about structured content a lot, and we have different course materials to explore that topic further too. So let's dive in and create our first schema type in our Sanity Studio. First, we'll create a new file. We'll call this event type inside of our schema types directory, and we can paste in the code example here. We can see that Sanity package gives us defined field and defined type helpers. These are optional, but they do give us type helpers with TypeScript files, so they're worth using because they'll catch some errors in your configuration should you accidentally make any. We can see our Studio still hasn't updated because even though we've created this file, we need to import it into our schema types here. So let's go and say we'll get that event type and import that from our event type file. Now we can see our Sanity Studio has updated with this document type. Zoom this in so we can see it a bit better. And now I can list all documents of the event type, which there aren't any at the moment. I can create a new document given this field. So we can see as we add new schema types to the Studio updates, and then we can create content on that shape. And our field types can be expressed, anything that sort of JSON can express. And our field types can be pretty much anything that can be converted to JSON because that's what all this content is stored in. So we can have Booleans and strings and numbers and arrays and objects. Let's go and create two more schema types, one for the artist type and one for the venue type. These won't show either until we register them. And thankfully, Cursor's picked up how this is supposed to work. So now if we go back to our list, we've got events, artists, and venues, and I could go and create documents of those types as well. Before we go any further, I'd like to add a few more fields and do them one by one in the event type so that we get to see what it's like to build out a schema and understand the different types of fields that are available to us. If we go back and have a look at the event type documents, and I'm going to go back to the event type schema here, I can see that I need to add a few field types here. So let's get a slug field. We can call this slug. And this will be a type of slug, which is a special field in Sanity to give us a few extra options. Also need a date field. And this will be a date time field, actually. So let's go date time. See Cursor's being a little bit optimistic here, which is a bit annoying at the same time. But it can usually guess exactly what I like. So I'm going to get a doors open field here, which is going to be a type of a number. It's going to show like the number of minutes until the doors open before an event starts. We need to add a reference to a venue. So let's say that this is going to be the venue field. That's going to be a type of reference. And a reference is a very special type of field which is going to link one document to another. And that strong referential integrity is going to become very important. I actually don't want an array of artists. I just want one reference here. So we can say thank you, but that's not entirely correct. Oh, no, now I've really gone and done it. Cursor is really blowing. So I should have just done this manually. Thank you to the type of artist. Yes, that's right. We need actually, and the artist one is going to be called headline in our schema here. The description field is actually not correct. I think at this point, Cursor's actually being less helpful than more helpful. I wanted an image field next. So we get an image, and then a details field. So this is like details on the event. This is going to be a type of an array. And a special array type in Sanity is when we have a type of block in an array. So if we have an array of blocks, that's going to be block content. Kind of like you might be familiar with in Notion or Gutenberg. It's going to render the rich text editor that we call portable text. So an array of blocks renders this editor here. And I've just got one last one. I want to have a define field of tickets. And this is going to be of the type URL. There's going to be a URL to buy those tickets. So you can see here I've got my content fields all created. They have just basic titles and different types here. We can see we can upload images. We can reach out and choose other venues and headline artists to put all this in. But we've got a very basic functioning Sanity Studio at the moment. It's not great, but it does the basics. You can create content, and I can deploy this to my authors so that they can start creating content too. We'll do that in the next lesson. Before we go any further, I want you to see what it looks like to use a studio that's full of content. It's going to make some of the future lessons much easier as well. So we've prepared an archive file which you can download into your project and import using the CLI. All right, so I've downloaded that production file to the same folder as the Sanity Studio. And what I'm going to do is open up a new terminal window. So the development server is still running because I want you to see what it looks like when content is imported. And so I can, from inside of that apps studio directory, run this command, which will import the data set directly from that file, which I can just correct the path to here. So that's actually at the root of the project here. Remove that as well. And I'm going to import that into the production data set. And we'll see, because we have a real-time content backend, as these files are created into our content lake, we'll see the Sanity Studio update in real time. It's very impressive. There's my document imports. So I can see now what it looks like with these content documents already filled out. And many of the artists have images as well. So I can jump over to the artists here and see those too. Excellent. We've got a Sanity Studio, a couple of content types, and a whole bunch of placeholder content. Let's get this studio up into the Sanity Studio hosting so that you could hand it off to authors and they could start creating content straight away. Sanity Studio is just a React single-page application, so we could host it anywhere. We can host a React single-page application. However, it's becoming increasingly popular to put it on Sanity's own hosting for a number of reasons which will become apparent as we go along. So from the terminal here and within the Apps Studio directory, I can run pnpm run deploy. The first time we do this, we will have to add a host name, and I'm going to call this one day one content operations, and I'm going to put my name on it because it needs to be unique, which is now going to build the studio. It's also going to deploy the schema, which is going to become useful in future lessons as well. And I have my URL, which I can go and copy straight away and open this in my browser. And I'll see that same Sanity Studio with the same content. And this is really important to note as well, is that because the content lake is where our content is hosted, it is pointing at the same content in the deployed studio as it is locally. This is really useful. It can be quite dangerous. This is where sometimes it's useful to have a development data set and a production data set, because it is possible locally in development to target production data. In your future, more mature projects, you'll probably want to have more than one data set. But for now, we're just going to YOLO everything into the production data set. It works for us. At this point in the course, you might want to jump out and do the Studio Excellence course of lessons. It's going to go deeper on configuring the Sanity Studio, so it goes beyond just the defaults we've set up now and into something more excellent. I strongly recommend you go and take those lessons next, but if you're in a hurry, let's just jump on straight into the next lesson in this course. Welcome to Studio Excellence. If you're here, you probably should have already completed the Day 1 Content Operations course, or at least started it to the point where you were redirected over here. You should have a Sanity Studio with a few schema types just like this, and we're going to go beyond the basics of setting up a studio and creating a really actually excellent editorial experience, which is the key to the reason why Sanity is such a great platform for developers. It's to create those great editor experiences. So let's begin in the next lesson. All of our schema is currently set up to just use the defaults, and so the editing experience really isn't very good at the moment. There's all sorts of things that we could do to make sure that as authors create content, it is valid and consistent and much safer to use. So let's go ahead and update the event schema type to make it a much better experience for our authors. First of all, the slug field would really benefit from having a source option. This means that we can generate a slug on demand by using the value of another field. So here in the options key, we can add a source of name. And this will add a button to the UI for the slug field. And it means that if this slug field was empty, I could go ahead and click generate, and it will go and make a brand new slug that is consistent and valid every time. If you were following along with me on the video, you might have noticed that I actually missed one of the fields, the event type field. Let's go ahead and add that field to our structure, and we can see that at the moment this is just a string field which anybody could type in any value. And if we want this to be a filter in applications, we're going to need to make sure that it is always written consistently. So our string field can take an array of options. Let's go and add that now. I'm going to say this needs options itself from a list where we can have in-person or virtual events, and we'll choose the layout of radio because I want this to be much simpler to click on. So now we can see that an author can only choose one of these two values, and that's going to make our data much more consistent. We can also set initial values on fields. So the doors are open. Perhaps always it's going to be an hour by default, and that only needs to be changed after the fact. Some fields will benefit from initial values so that they're already set when you create a new document. This won't have impact on existing documents, but if I go and create a new event type document here, you'll see that the initial value for doors open is now set to 60 already. But this field is a little bit confusing on its own. What does doors open actually mean, and why is it a number? Well, adding descriptions to fields like these is incredibly important to help authors understand, particularly new ones, what they are supposed to be entering into these fields. So let's go and add a description to this field so it's much clearer for our new authors to know what to do with this field type. And if a document shouldn't be published until it has a particular field value, we can add validation rules, whether they're very simple or very complex. For example, we don't want to publish any documents here of this type that don't have a slug. So we can say this one is actually required, and we can customize the error message, which is really useful. So here, if we start typing a new event, we can see that this slug field has become invalid, and we can see the custom error message to say why this field is invalid. And this is really important to give that feedback to your authors. Our validation rules can be even more complex and based on the value of the field themselves. So for example, down on the venue reference here, we can say that if the event type is a virtual event, it can't have a venue. So let's go and see this one in action. I'll go and add a venue to this particular document here and say, actually, it's a virtual event. Well, now I get a validation error on this. It says only in-person events can have a venue. So here we can validate fields against other fields in the same document. And that gives you those really complex rules to make sure that documents meet a certain editorial standard. We might also choose to hide or make read-only some of these fields, and we can do those using logic as well. So back up on our slug field here, let's say we don't want to see this slug field until the document has a name. So here this field will be hidden until the document has a name, because it doesn't really make sense to ask for a slug until we want to generate one from the name field. By the same token, we might actually not want to have a venue reference be written to if the document type is virtual event. So here we can protect ourselves even better than a validation rule to say if this field doesn't have a value and the event type is virtual, we can see how that field becomes read-only on and off based on the value of another field. And at the moment, all of our fields are just in a single column. We can do much better than that as well. We can actually group fields into groups. So we can add this configuration to the top of the document here. We can say we've got two different field types, details and editorial. They can be set to default. We can see they haven't actually appeared in the editing window here because none of the fields currently have groups. So I'm sure Cursor is going to really enjoy giving me all of this information. You can put fields into multiple groups as well by supplying an array. I'm just going to let Cursor choose which group these go into and go and save that. And now you can see I've got all fields. I can go to just details or just editorial. And this is a nice way to let authors be able to interact with just the fields they need, especially on very large schema types. And now we're largely done editing the content editing form itself, but if we have a look back at the document list, this really isn't very descriptive here. So we can actually modify what these previews are going to render as in the Sanity Studio by configuring the schema type itself. I'll just collapse the groups and fields so we can see this in its simplest form. And we need to modify the preview key of the schema type in order to update the preview in these lists. Before I do that, I'm just going to open up my terminal here, open up a new terminal process, go back into the Apps Studio folder, and I'm going to install the Sanity Icons package. This isn't installed by default, so we need to install this dependency, and I'm going to use Sanity's own icon package to customize what these previews look like. Let's go and grab the calendar icon from Sanity Icons. We can give this document a calendar icon as well. Now let's go and add some document types to the venue type as well. Map pin icon sounds good for venues. Oh, does it not exist? We've got a pin icon, I know that. There we go. It's an unhelpful hallucination. And we also need to go to the artist type and we can import a user icon will do. I think I'd rather the users icon, actually. And now we can see these documents at least have icons here, which is going to be really helpful when we search for documents to be able to see the difference between them. And we can see those icons are now in use on this document list as well. But we can customize this much further. Let's go back and have a look at the event type and go and customize the preview key itself, as I mentioned earlier. Here we can select individual fields from the document and place them into particular slots in the preview key. So here we've got the title, subtitle, and media. Those are the slots that render into this preview list over on the right-hand side. And so I'm saying for the title, use the name of the document. For the subtitle, use the date. And for the media, use the image if there's one uploaded. Otherwise, it should fall back to the document's icon. And so we can see here now we have a bit nicer and a bit more information. The date's not really formatted as well as it could be, but we have a bit more information there, which is useful. But we can customize this even further to not only render values as they are, but intercept those values and then mutate them and show them in a different way inside of the preview. So I have this massive code snippet here I'm going to grab because we're going to do some quite heavy optimizations to the preview key. Here we're going to take the name, the venue name. We're going to follow that reference to get the venue name, the headline name, get the date and the image. We can format the date, we can format the name, and here now we have much better information about the events, a much more nicely formatted version of the date, the location, the artist, and all of this information. So these document lists are much more useful now to editors as they're moving through multiple documents in the Sanity Studio. So if we have a step back and look now at what we've got, we have a much more comprehensive document editing form, document lists, and this is a much better experience for authors to write content in. And it didn't take a lot of configuration to make it this way. We can go even deeper, but this is a great first pass at improving the editing experience much more. Let's do a quick review on some of the changes we made in the previous lesson and how much further we could have gone. So when we're looking at define field helpers, we've only defined the names, and the title will be automatically generated. You can see how it's been given a capital letter here. This is enough in most instances, but you can manually set the title if you'd prefer it to be something very specific or cased a specific way, like a brand name. We've only added one description to one field here, but just keep in mind for any field type that requires a little more explanation to know exactly why this field needs values in a certain way, it's really important to put a description in there so your authors can understand what's required. We've used a few validation rules, but at the moment we've only used required. We could also use warning instead to just let users know that maybe this could be better. But using these rules for warnings, errors, or even just information is really important for content governance and content quality. It's also good to consider the order that your fields are being rendered in. So for example, because date and doors open are closely related, it's good that we've got them one after the other. So keep in mind, what is the most logical flow when authoring content? For example, if the slug is going to be generated from the name, we should have those one after the other. And as we did before, we've hidden the slug field until the name field has a value. But also the date and doors open field being related to each other, consider the flow. As I'm authoring a new document, what am I most likely going to need to input next, and how should the form respond to values as they appear in the document? We've grouped fields into field groups, but there is also a concept of field sets where you can even arrange fields side by side. That might be worth considering for other field types, but we're just not going to use that in these examples here. There's so much more you can do with Sanity Studio Schema, so you're best to check the documentation for anything that won't be covered in these lessons. The main tool you'll interact with in the Sanity Studio is the structure tool, and at the moment it's just using default values to load in the schema types as we've loaded them into the Sanity Studio configuration. But we can customize the structure tool, and that's what we'll do in this lesson. Let's go and create a new directory and file here. So in my Studio directory, I'm going to create a new file inside of a directory called structure, and we'll just call this one index.ts. I'm going to paste this one in here. This is what it looks like to work with the structure builder. It's a little bit gnarly visually, I'll admit, but it's incredibly powerful. And once you get your head around it, you'll really enjoy working with it. If you ever get stuck though, we have documentation. We've got lots of really good examples in a structure builder cheat sheet, which you can just copy and paste into your project. Just like our schema, just because we've got this file in our project doesn't mean it will be used. Let's go back over to our Sanity config, and inside of the structure tool configuration, we can import this structure. I'm going to import that file there. So at the moment, it's exactly the same because we've just shown the events, artists, and venue types here. If we were to change any one of these though, let's go and hide one of these elements. We could see that events document type would disappear. So let's do something more useful. I'm going to remove this list of just the event, artist, and venue, and instead paste in a few different filtered lists. So now I've added some dividers with a title on them so we can see that I've separated these document types away. And the first list here is a list of upcoming events where I've got my first GROQ filter, which we haven't touched on yet, but we're going to get to in future lessons. We're going to say documents of the type event, only render them if the date is equal to or greater than now. So here's our upcoming events in this list here. And then I have my past events showing into separate lists. So this is useful to our authors. And then I've separated away artists and venues into their own sections. These lists are still functionally the same, but it's just a much more useful separation of concerns and document types. What we can also edit with the structure tool is what the default document pane looks like. So for example, when we're looking at any artist, at the moment, this is all we're seeing is the default document editing pane. But what if I wanted to see all of the events that this artist is referenced in? Well, then it would be useful to customize this pane to show another pane alongside it. Now, there is a plugin to help us do this as well. So I'm going to open up my terminal, and inside of the Apps Studio directory, I'm going to install the Sanity plugin documents pane. This is just a convenient component which can take a GROQ query and render a list of documents that satisfy a certain condition, and perhaps use some values from the document it's being rendered next to. And now let's go and create a new file for the default document node. So inside of my structure folder here, I'm going to create a new file called default document node.ts and paste in this configuration. So what this is going to say is when it looks at what schema type of document is being loaded, if it's the artist document, then show the document viewer, the document form by default, but then show a separate view that loads in just this React component, the documents pane, which comes from our plugin here. And it's going to run this GROQ query. It's going to look for documents of the type event that reference this document's ID. It's going to take the ID value, and it's also going to pass in a perspective. We have preview drafts there at the moment. I'm actually just going to remove that for now, and we'll see if that's still in the code snippet by the time you see this video. We'll need to load this into the configuration of the structure tool itself. So let's go and add the default document node. Thank you, cursor, and import that from the structure folder as well. So now we have the default editor, but we can go over to the events panel here, and we can see here's one event that references this document. So we can see how useful it is to have the editing pane side by side with extra contextual information about the current document. So now we've put a custom component alongside the editing form. Let's go back to the editing form and show you how you can put custom components in any field at all. Because Sanity Studio is just a React app, there's all sorts of React-y things we can do inside of the configuration, like swapping out any individual form editing field and putting in our own components with our own custom logic. Now, you might use this to, say, take the name field here and completely swap out the way that this field is authored. Or you might decorate the built-in input with some extra configuration or details that help give context to the field. That's what we'll do in this lesson, but we've got a number of guides available on how to really customize any field type that you like. Of particular interest to me is this doors open field. It's still a little bit confusing. It's supposed to represent the number of minutes before the start time that people can be admitted to the venue, but at the moment I have to do the math on what is 140 minutes before this date time. Why don't we show what that value is and render it directly below the field? I'm going to create a new file here inside of my schema types directory. We'll create a components directory and the doors open input.tsx. I can post in my code snippet here. At the moment, I'm just going to render this component so that I can see how this looks. If we go back over to our event type, we can find the doors open field here. And yes, the components key will have the input of doors open input, which needs to be imported. There's a number of locations where you can import components, such as replacing the entire field or just the editing box. Have a look in the documentation to understand where these things are configured. But all I've done is configured the input, which means all I should see is my debug component with a nice red border there with the words doors open input. So you can see we've swapped out the default rendering of the input and just put in our component. This means we can do literally anything. Before we build a useful component, let's go and install Sanity UI, the front-end library for creating Sanity Studio. Inside the App Studio directory, let's go pnpm add Sanity UI and copy over an updated version of this same component. At the top, I've just got a helper function here, which is going to take the number of minutes away from a supplied date. Ideally, that's going to be the value from the date field and the doors open number. We can get that date field value using this hook use form value and give a path to that field. Here we're using this function, props render default, which is just going to render that default input. So we still get the same input that we had before, but we're able to render that along with some extra content, including a nice little bit of text here, and then our function, which is going to take in the date field value and the props value, which is the numbers in the field. It's going to then format that date and render this below. And we can see here we've got doors open 1st of March at 5:39 a.m. It's an early morning gig. But you can see now as we make this change, we get immediate feedback, and it's contextual feedback, used values in the document. This is really great. So this editing experience is so much better than it was before because we know immediately when I've made a change to this field, that's what it means to the rest of the document. And this is more complex and dynamic logic than the Sanity Studio schema is designed to give you out of the box. So it means at any point, if you need to get more complex than what we offer by default, you can insert whatever sort of logic and display rendering that you like. As you work with larger content creation teams, you'll begin to notice that not all editors are created equal. Therefore, you'll want to customize the Sanity Studio experience depending on the level of permissions that a user has. There's a number of ways the Sanity Studio can be configured to look and act different depending on the user's role, and we'll explore a few of those options now. A popular example is to make sure that not everybody can edit the slug field, because a change to a slug could have big consequences on a website. So here we can add a rule that says that the slug field is read-only if the user is not an administrator. So if we go over to the event type field now, we can see that because I am an administrator, then I see it here. But perhaps what if we just reverse this rule to say, oh, actually admins are the ones that can't change this field. We can see here now it's been disabled for me. This is a good way of showing the content to all users, but making sure that only a certain subset of users can actually make this change. Likewise, not every tool in the Sanity Studio is useful to every user. So the vision tool, which is somewhere we can run GROQ queries in a later lesson, might be better off hidden from non-administrators. If we go over to our Sanity config for the studio, we can go and add a key for the tools. And in this setting, we get all of the previously rendered tools and the current user. Once again, we can check, is the current user an administrator? And if not, we can get rid of the vision tool. So we can see now, because I am an admin, I still get the vision tool, but anybody who's not an administrator wouldn't see it any longer. So that's just two small ways we can modify the Sanity Studio configuration depending on the user's roles. But consider further how you might narrowly focus the experience so that the authors stay on rails, essentially, and protect them from themselves as they work on content throughout your Sanity Studio. Since Sanity is a headless content storage backend, it can be really useful for authors to be able to see the impact of their changes before they press publish. We won't set up visual editing in these courses. We have other courses available for that, but I want to demonstrate how powerful visual editing can be when you're using Sanity. And I'm going to demonstrate that by updating something which I showed off in a previous lesson I didn't need to have in the code snippet anymore. So here's my Mastering Content Operations course, and I can find the Studio Excellence course. And I think it was the lesson where we set up the structure customization, and I'm going to jump over to that on Sanity Learn. So now I've jumped from the document into the presentation tool where I'm looking at a live preview of this same document. But what I can do is click to edit any piece of content on this page and go directly to the document and the field where it's written. So here's my documents pane detail here. I can click on this and I'm taken straight to that code snippet where I know I want to remove that perspective preview drafts option. So now I can close that and publish. So you can see how fast that was to be able to use the website itself as a means to navigate the content, to go and make a change immediately, see a live preview of it as I made those changes, and be able to click publish and get on with my day. Visual editing is a huge unlock for authors, particularly in a headless context, and is well worth your time setting up on your front ends. Your Sanity Studio can be extended with plugins basically just being an encapsulation of a Sanity Studio config itself. So a plugin can register new tools, new schema types, new document actions, all sorts of things. So if we have a look at some examples, the media browser is a very popular Sanity plugin, and so it adds an extra Sanity image picking source, which you can remove some of those defaults if you prefer, but the media plugin is just a superset of features on top of the built-in image selector. We also previously saw the Documents pane plugin alongside of Documents in the editor. I've got a different studio here, which is a little bit similar to the one we're working with at the moment, but it renders an iframe to the right-hand side. So here we're rendering some other URL alongside of our document, but using values from the document itself to create the URL. This is useful for things like an OG image or an analytics URL, something that relates the content that we're looking at with some external URL to help the author make more decisions as they create content. There are many plugins out there that you can use. You can even build and distribute your own. If you'd like to encapsulate some amount of functionality and use it between projects, then plugins are a great way to extend that functionality to many Sanity Studios. Internationalizing your content authoring experience has ramifications across your entire content model and really changes the way that authors work. And so because of that, I want to keep these lessons really narrow and focused, and we won't touch that in this course of lessons, but we do have other material available for you. Have a look at the links in the lesson here, but primarily the best practices are all encapsulated in the documentation here. We show what most people do, but the understanding that you should take away from this documentation is if there's a better way that you would prefer to work with localized content, you can structure that. We have plugins available for field level translations. That's where every field has a language specific version, or document level translations, where there is a different document version for every language. And then we link all those together with what we call metadata documents. It's probably best that you go and read that documentation, have a look at that, see how the best practice Sanity Studio projects are set up for localized content, and we'll move on to the next lesson. The final lesson in this course isn't a technical one. We're not going to touch any more code. It's a social one. It's a reminder that Sanity exists to create awesome authoring experiences for those content creators. Now, it is also a great developer experience and a very flexible developer tool, but that's all in the service of creating great experiences to create great content. So work with your authors, speak with them often, get their feedback, show them preview builds of your studios as you're working through them, collaborate on schemas. You'll both have a much better time working with Sanity when you work together. There doesn't have to be a difference between you. Developers and authors can walk together in harmony. But thanks for completing this course. And if you're still working on the Mastering Content Operations track, go and jump over there and complete more courses in this track. Hidden throughout some of the lessons we've done so far have been GROQ filters. It's time to learn how to query content with Sanity. Before we do, you can use GraphQL if you prefer it, but GROQ is used in many parts of the Sanity platform and kind of is really the default way to query content with Sanity. You can think about GROQ as SQL for JSON, if that's a useful term, but let's have a look at just enough GROQ in this lesson, and then you can jump off and do a whole other course to understand it more deeply. Sanity Studio includes a tool called Vision, which we can use to run GROQ queries against any dataset in our project. The first thing you need to know is how to get all documents, and that's with the asterisk command. So if we type that in and then fetch, we'll return every document in an array. We can see we've got 456 items. You might have a few more, a few less in your data set, but this is all of the documents and all of the attributes within them. But what we can include is a filter to reduce the number of documents returned if they satisfy a certain condition. So we can filter this array and say only return documents where the underscore type field equals event. Now we've got just 180 documents and still every attribute within them. We can add more filters and stack them together so we reduce the number of documents returned even further. And GROQ includes a number of functions, such as the now function, so we can make sure that we only return documents that are after today. And even though we're reducing the number of documents returned, we're still getting every attribute in every document that's being returned, but we can change that with a projection. So when we add the curly braces at the end, we're saying we only want to get these particular fields off of every document that's returned. So let's get just the name field. We can also get that reference to a headline artist. However, we'll need to use this arrow to resolve that document reference. And from that reference, we'll just get the name field. We can also rename and add attributes. So here, let's add an isUpcoming equals true Boolean to the results. And now we're returning the headline artist's name. That isUpcoming is true for every document. And now the name of the event document itself. That is really just scratching the surface of writing GROQ. But the main three things you need to keep in mind, that asterisk to get all documents, square brackets to filter arrays, and then a projection to reduce the number of attributes that are returned in the response. If you like, you can jump out now to a separate course where you'll go even deeper on GROQ. But if you're still working through the day one course, let's go on to the next lesson. Say hello to your new favorite query language. If you're more familiar with GraphQL, Sanity does support that, but the primary way that Sanity users will query for content is with GROQ. You can think of it as SQL for JSON, if that's a helpful analogy, but it's a very quick to learn, powerful, and very flexible way of querying content. If you haven't already taken the day one course, it might be worth going and taking that first, because the Sanity Studio that we build in that course is what we'll use to run these queries in this one. Otherwise, let's move forward. The Vision tool is where we will run queries. It's a plugin that comes pre-installed in the Sanity Studio. You can see it configured in your sanity.config file. There's Vision tool inside of my plugins. And it looks something like this. We can save queries, but I'll just hide that out of the way for now. But we get to write a query and see the response on the right-hand side. You can change which data set it is targeting if you have multiple data sets, and you can have a look across perspectives if you want to try out that feature as well. Let's get started with our first query in the next lesson. There's three main things to know about running a GROQ query: getting everything, then filtering, then projections. Let's start our query with the asterisk, which when we fetch, will return every document in the dataset. That's not a very useful fetch because it's very rare that you would actually want to get everything. So we'll want to add a filter to say narrow down those results to satisfy the conditions inside of this array filter. Now it kind of looks like how you would index arrays in JavaScript, and you can actually do that. So I can say just return me the first thing. What's more useful is to write in a condition that needs to be satisfied. For example, the underscore type in every document needs to equal the word event. And now I have only 180 documents where they all have the same type. And while filtering based on type is kind of the most popular way of filtering down lists of documents, you don't have to do that. We can filter on any field. So say, let's only get documents where the slug.current field is not null. Now we get 179 items. In this data set, they all happen to be events, but we can filter on any field value in any document. Let's go and restore that filter as I had it before. We can stack another filter on the end of this list to do array slicing. So say I only want to get 3 items. We'll put in 3 periods there, and I want to go from item 0 to the third item, and there I'm returned 3 items. If I wanted instead to get the end item, so to include that number 3 in my array slice, we only put 2 periods in the filter there, and now I get 4 items returned in response. So we've got all the documents with asterisks, we've filtered them down to the type only equaling event, and then we've just returned 4 items for now. But we're still returning every attribute from every document. That's not always useful. So we need to add a projection, and that is curly braces on the end of the GROQ query, where we can say, I only want these particular fields, so let's get me just the name and just the event. And now I'm getting nothing. Let's actually put in date. That was the right one. There we go. Now I've got the date of the event and the name. You saw how when I named an attribute that didn't exist, I got returned null, and that's going to be important in a moment. But now I've returned just fields that exist. What I could have done also is stack an extra filter in there to say, only return me document types where the event is the type and that have name fields and have date fields. So you can reduce the number of results that are going to return null as well. And not only can we return values that exist in documents, but we can actually rename the response or even return arbitrary data as well. So if I put another item here and say is passed, and we can return this only if the date is less than now, and now is a function that will return the current time at the time of querying. Now I'll get this, and is passed is false for one and true for another one there. So we're essentially making up new attributes. This is a value that does not exist in the document, but is existing at the time that the query response is made. This is a really useful tactic to start moving logic from your front-end code into the query itself. You don't have to query everything and then post-process the results. You can actually put a lot of logic into the queries that you write. One more useful thing to know is that we can order the results as well. Ordering requires a pipe operator first, which says apply this to the previous elements. I'm going to add an ordering function here. And so let's order this by the created at in a descending order. So that's going to grab the created at field in these documents. Even though we're not actually going to return it in the response, we will use that data to change the ordering that we have. And so now we can see here that a field that doesn't have date, that's where it would have been useful actually to say if date is not null, that's what we want to return. So only return me documents that have dates. Order the responses by the created at value, which is a system field added by Sanity. Return only 4 items, only return these values from those documents. And you can see how we started with a very simple query, but we've built it out to be much more complex and dynamic and very useful for our front end. So that's how we get started with GROQ. Let's keep pushing further. We've seen a few functions in the queries we've been writing already. Let's unpack that even further. For example, we can actually just return the count of the number of documents that meet a certain GROQ query. So here we'll get that same type equals event query, but we'll just return the number of the documents. So here's an important distinction too. You don't have to return an array of documents in a GROQ query. You can actually return any value. And in this instance, this GROQ query is just returning a number. We've also had to check for some non-null values, and fortunately we have a coalesce function which says return the first thing that's passed to this function that isn't null. So what this is going to do is if the venue name is null, so perhaps there is no venue reference on the document, instead it's going to return this to be confirmed text instead. Similar to coalesce, we have this defined function which is going to check is this value null or not. And there's some even more complex functions, such as array functions, to say, return me only a unique set of array values from this. This is going to go through every event type where the date is in the future, where there is a headliner. We're going to return just the name of the headliner from those events. So this is a list of unique artist names that have upcoming events. There are so many more functions in the documentation, we can't possibly cover them all in the lessons. Go and check those out in the documentation. And after that, let's move on to the next lesson. In a few of these lessons, we've looked at references, and I've put a little arrow after that reference to go and follow that document. But what does that actually mean under the hood? So here I have my query again, where I'm only looking for documents of the type event, where the venue field is defined. Let's return just the first item from there and return the value of the venue field without an arrow to resolve that reference. And you can see what we get is the ID of that reference and a type for that field, which is just reference. And so here you can see that is all of the information that is stored on the event document. If we want to go and get the values of that document, we need to follow and resolve that reference. And that's as simple as putting that arrow on the end. And now we're saying resolve the entirety of that document, return all the values that it has. And just like the event document, we can add a projection to this reference being resolved and only return one value from that document. And we can do a sort of reverse lookup for references using a GROQ function. So here I'm looking at type artist documents and just return the first one. For that artist, only get the name and then return all of the events. So here we're making up an arbitrary attribute, which is going to run yet another GROQ query, and it's going to check for the references of this ID. Now you can see a little caret arrow there that's saying step up one level. So this is actually looking at the ID of the artist here. So that value there is being written into this references field. So essentially it's saying, get me all of the events that reference the ID of this particular document. And so now we're able to do that reverse lookup to say, get me all of the events that reference this artist, where previously we showed this is an event that references an artist. Go and get that artist. And we've seen a few GROQ functions in action now, which is great, but did you know you can actually write your own? Let's look at that in the next lesson. Our queries have been very simple so far, but when you end up with a very large GROQ query for complex types of content and repetitive bits of content, it can be useful to have a GROQ custom function to be able to resolve items in your documents the same way every time. Here's a simplified example where with my event document, I am having to resolve the name of the headline artist and the name of the venue. Now, in both occasions, we're taking a reference and pulling off just the same field value. What if we could abstract that to the same function and pass that value of that reference to a function that can always return the same thing? First, I need to declare functions at the top of the query. So we'll type fn. We need to give it a namespace, so we'll call it learn. And this can be like a reference resolver function, but we can just call it that. It takes a parameter, just one, and we can say that this reference that's passed as a parameter, we just want to extract a name. So you can see how this same handling of this value is what's happening here in this particular function. I can even put those spaces around it if that's helpful. I'll also put a semicolon at the end. And now instead of having to write this directly into the query itself, I can say this headline piece of data, we're going to use our custom function, and we're going to pass in the value of that reference. So here, this headline reference is now going to be passed to this function, and we're going to resolve it the same way. And so I can just copy this as well and say venue is going to be venue, and this should return me the same thing. No, what have I lost? Is it white space sensitive? No, I didn't put a comma after it. There we go. Close. And so what this means now, say that there was another field, like perhaps they all had slugs, we could go and add that to the function, and then we're resolving both of those references the same way. So again, this is a very simplified example, but you might imagine how when you've got an array full of objects and you've got 12 different ways to handle objects, but you want to do them the same way, maybe you've got people whose names need to be handled in the same way. Now you can abstract all of that logic away to a function that can be reused multiple times in a query for the same output. In the same way that we've compounded filters together to get all documents that satisfy these conditions and then only return the first one, we can stack projections together as well. So here we are again with our headline and venue names, where we could take those strings and do more with them in a following projection. So what we can do here is open up a second set of curly braces, and what's going to be accessible here is not every value in the document, but only every value that was in the previous projection. So now I know I have a headline.name and a venue.name available to me here, which perhaps I only wanted to return a string. So let's say the title of whatever we're going to render is the headline.name, and we can use some string concatenation here, venue.name. Now we can dynamically generate this title string, and we have just this title. Perhaps we wanted to just grab that attribute off the end of the object there, and so now we've got just the title being returned. But this is something that we've compounded together with these chained projections. You might not always use this, but it's kind of a way to set up variables in a query as well. So what you could do is, if you wanted to still return all of those original things as well, let's get that whole object back. We can say still return everything that we found before and this new attribute too. So that's a really clever way to grab some additional logic and turn the values in your query into variables that can also be reused throughout the projection. All the queries we've done so far have used static values, but in your applications, you're most likely going to need to feed dynamic values into your queries. And that's what we'll look at here. So probably the most common thing you're going to do is take the slug from a router, say a Next.js or React router, and you're going to pass that value to match some document in your data set. So here I've got my parameters slug, and that is represented with this $ slug. So it checks first, is the document type event, because our slugs won't necessarily be unique across the entire data set. And then look for just the slug.currentValue is slug, return the first document, and there that's what we've got on the right-hand side. Now, it's tempting in a JavaScript environment to, instead of using query parameters as they're designed, to instead use string concatenation. I'll try and demonstrate it here. So you might write some sort of query like this, where that's a JavaScript variable inside template tags, and then you need to put quotes around that because that would otherwise be just interpreted as a field name instead of now it's a value. I would recommend that you don't do that. There are very small circumstances where you will need to do that. But if you are sending in the value of a variable into a query, it is just best to use parameters, and they can be done conditionally. So let's look at a very different query for document types, and this is deliberately erroring at the moment. I'm filtering down to just documents of the type event. Then I'm using the select function, which is going to look for what is the first thing that is not null, and then apply logic to the right-hand side of this operator. So here it's saying, well, the first line is date defined, and at the moment, date's not even in the parameters, so it throws an error. So first of all, we need to say, well, let's put in a parameter of date, and we'll just set it to null for now. So this now is going to say, select what's the first thing that's not null? Well, is date defined? Well, it's not at the moment, so just return true. And that would effectively be the same thing as if we had just put true in here. It has no effect on the filter. But if we have a look at our select again, is defined, is the date parameter defined? Then if so, only return documents where date is greater than now. That is, things are in the future from the current given date. And you can imagine how this logic could be applied to some front-end filtering. So let's pass in a date value. I'm just going to pass in this value for now. And so this is the date that is defined. Yes, it was defined in the parameters, so use it to compare against the now function, and we've got different things returned there. And this is a way of doing conditional parameters. You still have to return a parameter, but you can work out is it null or not and still get up-to-date results. There are ways to make sure that fields always return a value, because it may be better for your front end to return something rather than null or undefined. If we take a look at this query now, again, I'm just querying for all documents of the type event and returning the first one. We can see we're getting every attribute from every document. However, as soon as we add a projection, it changes what we will get in response. So if I type in like fake attribute, like this, it doesn't exist on any document, I'm going to get null. Now that value would never have appeared in any of the documents, so it would never have returned as an attribute in any object. But as soon as we've declared an attribute in a projection, it's going to return with a value if it exists, or it's going to return null. And that might wreak havoc on your front end because null and undefined can be handled differently in different situations. So in instances where we want to make sure we always return values, we can use functions like coalesce. So in this instance, instead of just saying, get me the headline attribute, what happens if there's no headline attribute? Then we get null instead of a string. What we can do instead is say, what is the first thing that doesn't return null? Well, headline name does exist on these documents, so return the headline name, but if it didn't, return the word unconfirmed. That's a choice you'll need to make. Do you want a particular string? You might want to just return an empty string. So you're always getting something of the string type, but this at least would be a falsy string. So you're always getting a string, not string or null. When you take the TypeScript course, you'll understand more about this. You might also do the same for arrays. So the details field is a block content field. And again, if we didn't do this here, let's have a look at what it would look like. The details field is empty, so it's null, but we can return an empty array instead. So if we return this, we still get the same key name, but we are coalescing once again. Return details if it's not null, otherwise return me an empty array. So now we're not having to check, is it an array or null? We just check, does the array have a length? And when it comes to Booleans, I think you should just not use them. You should use string literals. They're much more extendable and they can still give Boolean-like behavior in your logic. That said, if you do have one, so imagine we had is sold out as a Boolean valued document. We don't, so they're all returning null at the moment. But imagine you did. You have the possibility that that would be returning true or false or null. Now, null is falsy, but if we want to return a Boolean, I want to return a Boolean, just true or false. And we can ensure that. So let's say is sold out, again, that same attribute name, but we're only going to return is sold out equals true. So this is now only going to return true or false, and we get an explicit Boolean like we're expecting. And so with that, we're done with all things GROQ. If you're still working through the day one course, hop over there and complete that. Otherwise, see what else you can learn about GROQ. There's some wonderful courses available and much more details in the documentation. Go and get it. We've configured your Sanity Studio, but that's just going to be one application you're likely to create when you're working with Sanity and other applications like a front end. So for this lesson, we're going to set up a PNPM workspace so we can run multiple applications, development servers at the same time more easily. This is going to require us creating a few files. First of all, at the root of our entire project, we'll make a new package.json file, and we can just paste in our details there. And so you can see here we can run our dev processes in parallel. And this is the main benefit of working with a PNPM workspace, is that we'll be able to run multiple development servers in parallel. We'll create another file to say where all of our apps are in this workspace. And we can put a README at the base of the project as well. And because we may end up installing packages at the root here, we should add a git ignore file, which is going to ignore any node modules folder. And so now from the root directory of this entire folder, let's just clear the terminal there, I can run pnpm install, and this will install all dependencies inside of all applications inside of the apps folder, such as the Studio folder that we already have. I'm just going to go back and kill all my other terminal processes, such as the development server for my Sanity Studio. And now from the root directory, let's go back to that day one folder, clear the terminal again. I can run pnpm run dev from the root directory, and this will run every application in the apps folder all at the same time. Let's just do one more thing to tidy up the Git history of this project. When we initialized the Sanity Studio, if we have a look in Apps Studio, you can see that Git is already initialized here. We need to remove the Git folder from this directory. So I'm just going to remove that Git folder from the Studio and then go back to the day one folder, and I'll run Git in it here. So now our Git is initialized in the root directory of this project, so we can track our Studio and our future front end or our other applications all from the root directory. We're now well set up to create more than one application. Let's start that by creating a Next.js front end in the next lesson. All our content's in the content lake, but we really want to share it with the world. Next.js is maybe the most popular front-end library going at the moment, so let's create a quick Next.js application to query and render our content from Sanity. From the root directory of our project, I've got a snippet we can paste straight into the terminal here. And like the one we did with the Studio, it's made a whole bunch of choices early on. We can have a look at those flags. It just chose Tailwind, TurboPack, PNPM, a whole bunch of choices. And what we should have is our apps folder with the Studio and with the web folder. And the web folder is where we put that Next.js application. And now from inside of our Next.js application, that web folder, I'm going to run this install command to add the next Sanity package. Next Sanity is a collection of utilities that make working with Sanity and Next.js together very simple. And now in my other terminal process, I can go back here and just restart this. And so we can run pnpm run dev from the root directory, and we'll see how two processes are starting up. We can see both the Next.js server at 3000 and the studio at 3333. Let's go ahead and open up that Next.js application. So inside of our web folder here, I'm going to create a new directory in the source folder called Sanity and add a client.ts file. Oh, let's put it inside of the app directory. We don't want that. We want source app. No, we want source Sanity client. And here we can bring in our Sanity client configuration. You will need to replace this with your project ID, and you'll be able to find that in your Sanity config file. So I can just go and copy my project ID from there and paste that in. In a production project, you would be inclined to store that as environment variable so that you could then share it between projects or maybe even a PNPM workspace package. But that's a bit of complexity we're not going to touch. For now, we can just copy and paste this into this file. Sanity Client is the typical way to interact with Sanity's APIs inside of JavaScript applications. But with Next.js, we make it simple to do live by default data fetching. So let's set up these live utilities in this file. And so we have a Sanity Live component. Let's go and add that to our application layout. And we can update the home page. That's this app page.tsx file. I'll hide the file browser and replace this entire file with the code snippet. So what we have here is our events query. So here's some GROQ looking for an event that have slugs defined, where they are future events, ordered by that date field, and then a projection to pull down just these four attributes. We're using this Sanity fetch helper that came from the live utilities and returning this data into the page. For now, we don't have TypeScript types configured, but we're going to take a look at that in another lesson soon. So now we have a home page where we're rendering a number of events, but I can't click into any of them yet. I'll get a 404. We need to create a new page for specific individual events using the slug as a parameter to find the right document. So to do this, we can open up the file browser again, and inside of the app directory, we need to make a new directory called events, and inside of it, a directory called slug with square brackets. And then within that, our page.tsx file. That slug parameter will be taken from whatever URL we're looking at, and that will be a variable available to us in our query. So now in this file, we have our event query, which is looking for a document of the type event that matches the slug parameter that we're passing in. It only returns the first document that it's found. It returns all attributes in the document, as well as a few renamed ones and some references being resolved. The params comes to us from the Next.js router, and we can feed that directly into the params in the query. If no event matches this slug, we return not found, so we still get a 404. Otherwise, we just grab all of that data, change some of it, and render it into the page. And so now we can see our Sanity content rendered onto this individual page. And we could go back to the events, click on any of these. We can also see the Live Content API in action by opening any document, going and making changes, and pressing publish. And we can see how briefly after that page is updated. This is what it means to build a Next.js app which is live by default. This is real-time information in our Next.js application just by inserting that Sanity Live component into the layout. So we've rendered text content into our front end, but Sanity has a CDN for images as well, so let's render those in the next lesson. Sanity has asset storage as well as an image CDN with transformation pipelines so that with the right URL, you can serve the right image at the right size for your application. The simplest way to configure this in our application is to install a package called Sanity Image URL. We can install this into our Next.js application. And because we'll also use Next.js's image component, we'll need to add some config options to make sure that it is aware and ready that there are other URLs we'll be rendering images from. Let's create another utility in our Sanity directory here. We'll call this one image.ts. And this is setting up our image URL builder function, taking the Sanity client to get the project ID and dataset name, and export a function called URL4. This is going to take any amount of image data from Sanity, including just the ID of an image, and turn it into a complete URL to render the image. Now, if we go back to our individual event page, we can add a few imports, such as the image component from Next.js, And we can import our URL for function from the utility that we just created. And now we can make the image URL dynamic. If we scroll down here, instead of just this placeholder, we'll say if the data returned a photo from the headline artist, then we use that URL for function that we just created and use the chained methods to return an image of just this height, width, quality, and automatically set the right format for the browser that it's being rendered in. Lastly, we'll switch from just this normal HTML image to the Next.js image tag. And now for any event where the artist has an image, the artist's image is being rendered onto the event page. That's just the beginning of rendering images from Sanity's asset pipeline. Make sure you check out the hotspot and crop tool with images in the Sanity Studio, and so your front end can render an image with the right dimensions and the right focal point that your authors want. Our front end's looking pretty good now, but it's still got those red squiggly lines from TypeScript, and we must fix them next. The content lake is schemaless, which means we can play fast and loose with the data that we put in there. And GROQ is super flexible, which is excellent for creating new attributes on the fly. But these days, everyone wants things to be typed. Fortunately, Sanity's TypeGen can create types for both our Sanity Studio schema and our GROQ queries so that we can get some type safety into our application. Before generating types, we need to extract the schema from the studio. So inside of the app's studio directory, we can run schema extract, and this will create a schema JSON file at the root of our studio. This file is really not important to us, but it is very important to Sanity TypeGen, which will create types from this extraction. Let's create a new file at the root of our studio to configure Sanity TypeGen with the following configuration. This says it's going to look in this path for any GROQ queries, and that's back in our web folder. It's going to use this schema file, which is the schema extraction file we just created, and it will generate types at this URL, which is back in our Next.js application. So the combination of the Sanity Studio schema and our GROQ queries in our Next.js application is what we'll be able to create types from. Now from the terminal, once again, inside the studio directory, we can run a command to generate types. And a successful result looks like this. It's created types for 14 schema types and our 2 GROQ queries, which it is found in the application. If we open up our types, we can see this is the file that was automatically generated. And if we scroll right down to the bottom, we can see our Sanity queries have ended up in these results as well. Unfortunately, automatic type inference is looking for this Sanity client package. And because we used Next Sanity instead, we just need to go and add Sanity client to our application. So let's go back to that web folder and add Sanity client. Now looking back at our types file, those red lines have disappeared. But even better, if we go and have a look at either of the front-end application files for our queries, we should see that this data is now typed. This is the event query result type, which knows that venue is looks like this. This is what our venue document looks like. And this is what our tickets value looks like. Here's what a date looks like. It's a string. So we've now generated types based on our Sanity Studio schema and our GROQ queries. This is excellent. Remember, you will need to rerun that schema extraction every time you change your studio schema. You will need to rerun TypeGen every time you change your schema or your queries. For this reason, it's probably a good idea in our Studios package JSON to add a few scripts to make sure that every time we start the development server or the build server, we run TypeGen. And this TypeGen script will do both of the schema extraction and the TypeScript generation. So at this point, we've got a really great stack. We've got a Next.js application that gets real-time updates. It's type safe, and we've got a Sanity Studio, which we can deploy to our authors. As your project matures, you might need to make changes to these types and these studio schemas. And if you'd like to explore that topic more deeply, I recommend you go and take this next course about handling schema changes confidently. Otherwise, if you'd like to stick with this course, let's see you in the next lesson. Welcome to Handling Schema Changes Confidently. Projects don't always get it right from the start. You've done your best job and best effort to plan out your content structure in its perfect format, and you might have shipped something to production already. However, circumstances change, content models change, and you might need to change your content model after the fact. Well, fear not, we have the tools that you need to get this done. If you have joined us from the day one with content operations course, you're in luck. You're ready to go with the right studio and setup. If you haven't yet done that course, you might be best to do the first few lessons in that course to get a project and a studio set up. Also, we have some dummy data that you can work with as we'll reshape that in this course. If you didn't import that during the day one course, make sure you do that now. The details are in the lesson below. And if you are ready because you've done those things, well, let's go and get started in the next lesson. Before you make large-scale changes to your content model and your content, it's probably best to validate that the data that you have in the dataset meets the rules of your schema types. And if you've worked through some of the prior course material, you've added some validation rules to documents, and we can have a look from the command line how many documents satisfy those validation rules before we make wholesale changes. So from the command line, we can use the Sanity CLI to validate documents by running this command. It's going to ask us some questions first. We can pass a flag in to not be asked this question in future. And so I can see that in my data set, I have just one validation error, and I can just copy this document ID, paste this into the search box in the studio, and get sent straight to that document. And I can see here, it's just I don't have a slug on this particular document at the moment, and now we're all valid. I can rerun this now with the Y flag. And all of my documents are now valid. This is a really great check to do periodically and maybe as part of your CI/CD pipeline as well, once you configure that. But now we know all of our documents are in a valid state, we can begin to make some changes. In the following lessons, we're going to follow the journey of changing a field name in our content model without losing any data and causing any downtime in our front ends, as well as giving authors the understanding of what has changed in the content model. Let's imagine we've gotten feedback that the event type field is a little bit confusing, both in the administration panel and in our code. We can inspect the document here and search for the event type field, and we can see that this event type is in person. Naming things is hard, and having instances where an event document has a field called event type is a bit confusing. It's not ideal. It's led to some confusion along the way, and we need to update. The first thing we'll do is add a new field called format to the event document type. This will eventually take the place of our event type field. And if we take a look in our structure here, we now have both the event type field and the format field. Studio Schema includes a deprecation attribute where we can give a reason which is displayed to the author as to why this field has been deprecated. Additionally, we'll set this as read-only to true so that this field can no longer be edited. Any authors that log into the Sanity Studio will now see that that field is no longer to be used. Before we migrate that content though, let's prepare our front end to read from either field. Now that we have two fields that could be the source of this value, it's fortunate that GROQ allows us to set custom attributes in a projection and fallbacks to prefer one value over another. If we look at the page route for individual events in our Next.js front end, this was created during the day one course, we can see here this ellipsis returns all values from the document, and then we have a few overrides beneath it. Now we can add to this query an event type attribute, which is going to use the coalesce function to return either the new field value if it exists, otherwise fall back to the existing previous event type field. So now our content teams can use the format field, the new one that we put into the schema, and if that exists, that will render into the front end, but will always fall back to that existing value while it still exists in the dataset. Sanity is so flexible that you can script literally anything, and that's great. But we have pre-built migration scripts and helpers to write them for the sorts of content operations that you need to do regularly when you're doing remodeling of content schemas. Creating a new content migration script is as simple as running the Sanity CLI. Here we're running Sanity migration create, and then we've given this migration script a name. We'll tell it to work on the event document type, and we're going to rename a field. There's some helpful instructions there, but I'll walk you through it. We can now open up this file, which has been immediately created for us inside of the Studio directory. And we can see here at the top, we have our old field name and our new field name. And this is the script that is going to run from the command line when we run it. For every document that satisfies this document types filter, it is going to set the existing field value from the from field to the to field, and then it will unset the from field value. This means we can now set the value of from event type, our old field name, and our new name is format. Thank you, cursor. Before we run our migration script, let's validate that this value exists so that all documents are invalid if they don't yet have this field. This will be helpful after the migration's run to ensure it's done exactly what we wanted. So let's open up our event type schema again. And when we find that format field, let's add the required validation rule. Now this document's no longer valid because it doesn't have a value. If we check the validation of documents now, we should see that all of the event document types are invalid. For the safety of your content, all migration scripts run in dry mode by default, which is very helpful. Let's go and take a look first at what this migration script will do once we run it. So from the command line, we can say npx sanity at latest migration run, and then the ID of our migration script. And here we can see all of the documents that were going to be changed and the actions that would have been taken on each. Before running a migration script like this, which will make changes to documents, it might be a good idea to run a backup quickly of your dataset. Fortunately, that process is very easy from the command line as well. From the command line, we can type in npx sanity at latest dataset export production. And this will export a gzipped file directly to our studio, just like the one that you may have already downloaded with the dummy data in it. And now the last thing to do is run our migration script again, but with the no dry run flag so that these changes are actually committed to the dataset. And there we have it. We see the studio has already updated in real time. That previous event type field, which was read only, now has no value, and that value has been transported to our new format field. Because we set a validation rule on the format field earlier that value is required, we can now run documents validate once again to confirm that this change has taken place on every document. So we can even go back up through the terminal and find that same validation command again. Perfect. All our documents are valid, all that content has been migrated, our front end hasn't taken any downtime, and our authors couldn't write back into that old field anyway. We're almost home. Now that our content is actually migrated, there's a few loose ends we can tidy up to finish this migration effort. First of all, we no longer need this event type field, so we could remove it from the schema, or we can just hide it for now. And our front end no longer needs this coalesce because the format field will exist and the event type field will not. And this red squiggly line reminds us that we have not yet rerun our type generation. Fortunately, we created one command to extract the new schema definitions and update the GROQ queries. Our content migration for this course is complete, but there are some tips you might want to keep in mind for future efforts for even larger content migrations. First of all, we can add a GROQ filter instead of a document types key, and our filter here is documents where the type equals event, where documents have an event type field and do not yet have a format field. This ensures the migration would never have run on documents that didn't have the old field and didn't yet have the new field. Sometimes documents can't be marked as finished just by GROQ filters alone. So here's a method for applying an idempotent key to make sure that documents are only migrated once. This key you could then remove from every document when the migration's complete. Here we've declared a value which we'll write to all documents that never changes. And here we're checking if this underscore migrations field on the document has the idempotent key already added. If it hasn't, then it will set an empty array at that value and insert that migration key to this array field. This is not a value that you'd need to add to your Sanity Studio schema because it doesn't need to be content editable by authors. It's just a measure of bookkeeping for your content migration and something you could remove from every document that contains it when you're finished. That's everything for the schema migration course. Congratulations for making it this far. We've got a few questions to test what you've learned in the quiz below, and good luck with the rest of the courses in this track. In this course, you've already configured Sanity Studio, which is the primary way that your authors will interface with content on a daily basis. But there may be times where content operations would be better performed by a purpose-built application rather than a one-size-fits-all Sanity Studio. And so for that, fortunately, we have the app SDK, and we'll build a very simple app in this lesson. First of all, in the terminal, from the root day one directory, we'll run this command to initialize a brand new SDK application. You can see a few flags that I've chosen. This one includes using the Sanity UI template. It's going to choose TypeScript, and we'll put this new app in our apps folder in our workspace. Choose the same organization that your project is inside of. And so now if we take a look at our folder structure, in our apps folder, we should have 3 directories: the Studio directory, our new tickets directory for our application, and the web folder for our Next.js application. We can also see this in our file browser. We take a look at the apps folder, and here's our 3 directories. We'll need to copy some configuration over from our Sanity Studio. So if we open up the Sanity config file, we can grab our project ID and dataset. And inside of this new tickets application, we'll find the app.tsx file. And here we'll see that same project ID and dataset. You may notice that unlike Sanity Studio, that only takes 1 project ID and dataset per workspace, the Sanity config in an app SDK app is an array, and so it can work across multiple project IDs and datasets in the one app. Currently, app SDK templates and the Studio run on the same port in local development, so we'll need to change one of those things to be able to run them side by side so we can see them work in unison while we're working in development. The simplest way to do this is to open up the Sanity CLI file in our Studio, not the one in our app SDK app, and add some additional configuration to this file to say that this Studio should now run on port 3334. And just to confirm, this is in the Studio directory. Before we restart the development server though, I'm just going to open up the terminal here, and from inside of the apps Studio directory, run this command to add a new cause origin. Every unique URL where your Studio runs will need a cause origin applied. This is automatically done for you when you start a local development server and when you deploy the Studio, but if we ever change these URLs, we'll need to update these settings ourselves. So now our Studio is set up to be able to run on port 3334. I'm just going to go back to my development process here. And now from the root directory of our applications, we can run pnpm run dev, which will run the dev server for all 3 applications. This means the app SDK app now runs at 3333. Our Studio is at 3334. And our Next.js application is still at 3000. Because the Studio and the app SDK are both real-time applications, and we've set up real-time data fetching for published documents in our Next.js frontend, this is why it's really useful to run these applications together, so we can see the impact of our changes in real time as we make them. If we have a look in the terminal for our development running processes, we'll find a URL here with this funny @ symbol, which will allow us to view the locally developed application inside of the dashboard. The dashboard is your home screen basically for all things Sanity. It's a quick way to be able to move between different studios and different applications as your project grows and the scope of your content operations grow with it. Let's start building out our application by creating a number of components inside of our app SDK app. So here inside of apps, tickets, source, let's go ahead and create a few new files, and I'll explain them as I go. So this first button here for publishing documents uses the use document hook from app SDK, which takes in what we call a document handle. A document handle is a data object that includes a document ID, document's type, project ID, and dataset from where that document came from. And they're used a lot through the app SDK to keep applications performant, just as like the smallest amount of information we need to know about a document in order to share it between many hooks. All this will make sense as we put the application together. So this use document hook will look up the document at the document handle and only extract the value of this field, the ID, which we're using to check if this document is a draft or not. We also have the use apply document actions. This is a way to publish, delete, revert, and take actions on documents like you do in the Studio. Let's create another file here, ticket url.tsx. This component uses that same use document hook to get a single value off of a document, and use edit document to edit a value on a field in a document. We then have a text input which will update that field value as changes occur. Let's create another component here, event.tsx. This component uses the use document projection hook, which gives us a way to take one of those document handles and return a number of attributes off of a document. In this case, we're just returning the name field value. Use document and use document projection are two hooks that seem to have similar functionality, but work a little bit differently under the hood. We're using use document on the values that we're going to edit because we want those to be real-time updates kept in memory, where use document projection only needs to be eventually consistent because we're just rendering the values of those fields. Now let's create another component here, events. And this is to list a series of event documents. This is using the use documents hook, which is going to query for documents of this particular type and return just document handles of all of the documents of that type. Use documents is a really performant way to query for a number of documents because it includes batching and caching, especially when compared to Sanity Client Fetch, which will just return everything you ask it for. And now let's go back to our app.tsx file. And instead of our example component, we can drop in the events component. And so now on the right-hand side here, we have our app SDK application, which is listing a number of events documents. It has an editable field input for the URL field on those documents, where we also have a button which is convenient. If there's a valid URL inserted, we've got an open button and we've got a publish button to publish any changes to these documents. But perhaps it's most impressive to view this application while we look at a Sanity Studio side by side. So here's the same document and here's our tickets field. And we should see as we make changes, we see them being written immediately to our Sanity Studio document. And not only did it write changes, it created a new draft document from the published version as soon as we started typing. I can now publish this document in my app SDK app. And we see it published in the Studio as well. This is an incredibly simple application, but you can already see just how fast it was to create a real-time, optimistic, custom application that looks just like the Sanity Studio and interfaces directly with content in the content lake. We have a separate course available, which is much more exhaustive and will explain all of these hooks in more detail. Really recommend that you take that next if you're working through the day one course, but if you'd like to skip on to the next lesson, I'll see you there. So far, we've only really been concerned with content operations that occur inside of the Studio or our own custom applications that all happen inside of the dashboard. But the content lifecycle goes so far beyond actions taken inside of a content management system. The next step is to take any action based on any document change from any source, and we can do that with Sanity functions, which are deployed through Sanity Blueprint. Before we can create a function, we need to create a blueprint. So let's go and open up a new terminal window. And we're going to do this inside of the Studio directory. We could put our blueprints and our functions literally anywhere and configure them however we like. But in this exercise, it's going to be simplest if we do it from inside of the Studio. It's just where a lot of our files are for now. In future, this guidance might change, so check back with the written guidance in the lesson. We can initialize a new blueprint from inside of the Studio using the command line with Sanity Blueprints init. Choose your organization and project, and you'll see a few new files have been created and a new dependency which you'll need to install. We'll also need Sanity Client as a dependency for the function we're writing, so let's install that package as well. That's just pm install Sanity Client. Let's take a look at the files that have been created for us. In our Studio here, we now have Sanity Blueprint.ts, which currently has a commented out function for us, which we'll need to set up in the next step. We could manually write new functions files, but instead, let's use the command line once again to initialize a new function file. We're calling this function first published because what it is going to do is add the date and time that a document was first published if the document doesn't yet already have that value. So let's just double check our file structure again. We now have a functions folder inside of the Studio, a first published directory, and inside of that, just an index.ts file. We can now go back to our blueprint to make sure that this function is enqueued. We could just edit this to say first published, but there's a few more options I'd like to give this straight away. This configuration will now make sure that this first published function will only run on publish events of documents, and it will be filtered down to documents of the type event and documents where the first published field is not yet already defined. This is incredibly important for functions that are going to run against documents that will write changes to the documents that executed the function. In this instance, this function is going to write to the field first published. Therefore, we should filter out any documents that already have that field. Before we update the code of the function itself, we can see here that all this function will do is log a string to the console. We can test this function from the command line using Sanity functions test and the name of the function, which is first published. And we can see here this same log in our function file here is now in the terminal. Let's update the code of our function here to set up Sanity Client. Here we're importing create client from the Sanity Client package. The context of the function contains a number of the config details that are required to run the function. We can disable the CDN because we're only using the client to write in this instance, and we do always need to supply an API version. We're going to patch the ID of the document that is being executed on the function. And we've got this patch set if missing, and that's the first published field and just the current date that the function runs. Lastly, we'll only commit this patch if the context of this function run is not local. This is an important consideration when we are handling live documents. We only want to test this function locally and test that it would make this patch. Therefore, we can set this dry run flag in local development and then make sure that when we deploy this function, it would actually make this change to this document. We can also send document data into the function while we're working locally. So if we open up one of the documents in the studio and grab its ID, we can use the Sanity CLI to retrieve this document from the dataset and write it to a local JSON file. So here we can go pnpm dlx sanity at latest, documents, get the ID of the document, and then write that to a file sample document.json. And now we've retrieved that document to our local file system inside of the Studio directory. All of this document data is what will be made available inside of our function. Let's open that up again. Inside of this event data, you can also set a projection setting on your function to only pull in specific values from a document. We can now test this function locally using that sample document we've just downloaded. So we see the patch successfully run, but just as a dry run, and the first published field was set on this document ID. We've tested our function works. We can now deploy this by deploying our blueprint. We can deploy our blueprint from the command line, and after a few moments, we should see success. So now our function is live. It's time to test it. Let's go and make any change to a document here. Press publish. And we can check the function's logs as they've run remotely. We can see here that the document was updated, and this should have been immediately apparent because we have this unknown field error. This is a good reminder that the Sanity Studio is just a representation in a point of time of documents. And so because this first published field isn't in our Sanity Studio schema, the Studio doesn't know what to do with it. So as one last step, let's go and update the event type in the Sanity Studio schema. And right at the bottom of all of our fields, add in our first published field. And because our function configuration filters out documents that have this field value, we could make more changes to this document and that function wouldn't run again. That's a small taste of what functions can do, but now you have the power to automate anything off the back of document changes. We have a recipes library for inspiration. Go and check that out. Otherwise, join me in the next lesson. Agent actions are batteries included, schema-aware AI tools for your content operations. For the history of computing, we've had to compute values off of logic, but now we can use plain language to describe the actions that we would like to take. So let's create a basic script which we can execute on demand to perform AI-based changes on content. Inside of our Studio directory, we'll create a new script which we can execute from the command line. Let's create a scripts folder and put details.ts in there. This script is getting a configured Sanity client from the CLI and then performing this GROQ query where it's going to look for the first document of the event type that doesn't have a details field and just return its ID. We'll open up the terminal and execute this script with Sanity exec. Here we can see we get a console warning about the VX API version, which is required currently for agent actions, and then we get the ID of the event that we've just queried for. Let's update our script once again to perform an agent action. We're now going to look for a document of the type event that has a headline and venue reference attached, doesn't have details, but is going to get the ID, the headline name, and the venue name. First, we'll retrieve that event and then use our agent action. In this agent action, it's going to create a short description of what attendees can expect when they come to this event. The headline artist is headline and the venue is venue. We can see these $ indicate variables, which are passed into this instruction params. And this agent action generate command is going to write to this path in the document. Let's open up a document so that we can see these changes take place and see our details field. And we can open up the terminal and run this script once again. Oh, I got an error. We need to pass in our user token because we're actually trying to write to the document this time. That was almost too easy. We just wrote fresh content to this document using values in the document. It was written in the portable text format and happened basically immediately. We've done this from a script on demand, but you could add this to buttons inside of the studio or a Sanity function so that it happens automatically. Agent Actions can do so much more than just editing existing documents. It can create new documents or even translate between languages. Go and check out the documentation for more that you can do with Agent Actions, and then I'll see you in the next lesson. Congratulations on getting this far, getting all through the day one course. I hope that you are also completing the other courses in this track to unlock certification. And when you get that certification, make sure to let me know all about it. Don't forget there is that feedback form in the bottom of every lesson. If anything seemed confusing or unclear or left out, anything more you want to know, please fill that feedback form out and we'll get back to you. Thanks for joining me.